what the scanner reports. The scanner records first and last returns. So I can always create a DSM before ground classification. It may have errors because we didn't remove the noise, but in the DSM we can also look at the noise. First only, I'm outputting a PNG. That's it, merge into one, first only, hillside shading, PNG, run. Here are my files, merge, first only. Oh, I didn't pick an output directory. Yeah, so I say cancel. Otherwise it's gonna go, who knows where it's gonna go. Output, and I also didn't give it a name, so I call it mastate dsm.png, and the output directory will be just there. In that directory, 2 kilometers. Use current. I put it inside the 2 kilometer _ 2 directory. So, again. You know what, it might be interesting to create, to show you that LAStools can also create individual. We can also create individual ones. Let's create individual ones. So now we create one for each. The output directory, we can leave it like it is, but now we must not give an output name. We must say output PNG. Oh, now I probably confused everybody, so I go back. You can also use LAStools to create individual DSMs. Now we're not merging them. It's actually, it might be better to actually look at the individual DSMs. Then, of course, you can also run it on more than one job. I have only 4. Everything else is okay. So now I don't merge them. I run on 4 cores. First only, elevation, hill shade, and I'm putting this into this output directory. I didn't create a directory now. I've gotten lazy. But now they'll all be together with the file scripts in one. There's only 4 scripts. Okay, mine is done already. And now I will finally find out where Masbate is. Because I will drag and drop it on Google Earth. And hopefully Google Earth knows better than me where Masbate is. Where are we going? Whoa. Whoa, there we are. Beautiful. So what you see here now, these are the edges of the individual DSMs, because we computed each flight line separately. So they don't have a nice match, because they all have artifacts at the boundary. But they do nicely match together, except you do see the artifacts along the boundary that we avoid with the buffer. It's very nice to see them here. I was hoping we would see the problems better. Maybe. Yeah, it's actually not as visual as I hoped. But I think this here, right? This is looking a little odd. But it's maybe better we look at the point clouds directly. Anyway, at least it helps me demonstrate that you can run blast them also on multiple cores, and it illustrates nicely that along the edges, if you don't take care of with buffers, if you don't use buffers, you get these nasty discontinuities where you very clearly see where the data was cut. And I also know where my spot is. Are those all cows there? Ugh, those big cows. Where are the cows? I don't see no cows. But it looks nice. The hills look really nice. You saw? You seen cows? You seen cows? Don't start counting them. Okay, you're gonna fall asleep. Okay, every LAStool is also a viewer, so we can view the files. Remember, if you only want to look at one at a time, that's always a good idea. You have to say selected file only. And if you say view, I just picked one of them. The viewer also gets that filter. I actually don't want that filter right now, so I can just delete it here. The first only filter. I want to look at all the points. These are my points. There are the cows. They're flying cows. The famous flying pigs. Famous flying pig Masbate. Yeah. So you get a lot of returns high up in the sky of the clouds, cows flying. But these are flying clouds. So we have our usual noise, and then we have really nice puffy clouds. And Sir Chris said 2 days ago they're flying below the clouds. Well, I guess his pilots don't all fly. They're doing. There were some really low clouds, and they couldn't fly below them. what are we doing? Look at this. Can we use last noise? Huh?
No.
I mean, last noise removes sort of isolated points. I mean, look at this. If I press first returns only, F, and I triangulate those, it looks like it's a huge tree. A really huge tree. Wow. So it's kind of funny in the DSM it didn't even look so bad. I thought it would look worse in the DSM, but it didn't because we look straight from the top down, so we only see the top ripples. But these kind of ripply fields, there was the clouds we looked up on top of. But if you look, I mean, it's totally destroyed, right? By the clouds. But these clouds are so dense, they look like actual structures. They're not just like these individual points. Those are easy because they're very far away from anything. But these form structures. So if I say with the filter, keep all the points that don't have any points in 10 meters, well, these have plenty of points in 10 meters because we are scanning the clouds. So there is a lot of beautiful scans of clouds, and we are here in LiDAR 2 projects. Maybe you can come up with a great study you can do with scans of top of clouds. I'm not sure anybody has come up with an application for that. What can you do with scanning clouds from the top? Because we have a lot of data on that. Maybe it's a PhD topic. Maybe automatic cloud classification. What kind of cloud is it? Is it a sheet cloud, or like a cumulus cloud, or hockey cloud, dangerous rain cloud? One way of doing it is if we have some assistance from the outside about where the real surface of the Earth is. At least if we had a rough idea that this is the true surface because somebody else told us the true surface is roughly there. And we can only get a true rough idea because remember, this project creates the detailed idea where the surface is. That's the whole point of the project. So nobody else knows this yet. It's a bit of a chicken egg. But we don't need a detail. If we knew roughly that this down here is the Earth's surface, we could just throw away everything that's too high above it, like a cloud. And which data source could give us such an idea? I mean, and we're not the first people ever, the Dream Project is not the first project ever to map the Philippines. So Philippines has been mapped before, not with LiDAR, but with other technologies. So there are maps already. They are not so detailed, they don't produce good flood models, but they can tell if a cloud or not, because they're going to be at least that good. So there's SRTM and ASTER data that exists that we can use to tell us, well, we know plus minus 20, 30 meters where the surface is. And so if it's 100 meters above that surface, it's probably not the surface. And where do those come from, Char? these Aster.
Downloadable.
Huh?
Downloadable.
They're downloadable? From where? From a website. That's awesome. They're downloadable from a website. Is it like the geodesy? The GSD? USGS. Wow. Okay. The USGS has them for download. Well, I mean, I figured somebody would know in this room full of geodesic specialists where you can get a Aster DSM. I suspected so because they have a very nice way of making data public available in the US. Because whenever it was paid for with public funds, it needs to be made available to the public, which is not an unreasonable strategy. If your tax dollar paid for it once, why you have to pay for it again? So, I hope we have them. Let's see, sample data, no. EGM, no. Aster, there should be somewhere a folder next to the sample folder that you have, which is called Aster. And in that folder, there's a folder called Masbate. And in that are two files. Let's use LASinfo to open them. LASview. So I'm going to LASview. Aster, Masbate. Now I can only see the last one. If I click here, then I also see the ask one. Actually, I think the USGS provides the .ask one, but the ask one is very inefficient because it's, as I said before, it's the ASCII format. So I converted it to the LAZ format. But just so you see how inefficient it is, let's double click it. And it already takes a while just to show up. Took quite a while. And then let's view it. View. And you can see that LAStools can directly view the ASC files. And voila. Here we have Masbate. Now let's do the same thing again, but with remove the ASC file again. Pressing delete and load the LATS file. And then say view. And it loads. But not only that, I also resorted it. I sorted it into an order that's more efficient for this kind of operation. Looking at the zoom, you can triangulate it. So that's the Aster. It's not super high resolution, but it should tell me at least which is the cloud, which not. Now there's a tool called LASHeight. I'm not sure we have used it yet. I don't think we have. LASHeight. Actually, before we do this, we should create a folder because we're not gonna remove the clouds. So we should go to 2km_2 and create a new folder called we still have strips, so strips. It's not really denoised, it's like declouded. You want to always use names so that tell you what you did. So they're still strips, so it's not tiles. I know I have not tiles yet, and I will decloud them. I already started the last height in the background. Now first let me just load the data that I will operate on, and it's going to be the sample data, Masbate, 2km_2, and all of the LAS points. So these are again my 4 tiles, full of clouds. They actually all have clouds, I think. If I look at some of the other ones, you'll see that they have clouds too. Yeah, there's a little pretty cloud high up in the sky. So, I'm running last height. With last height, you have the option of using external ground points. And we will use the aster as the external ground points. Because they are not super high resolution ground points, but they are good enough to remove the clouds. So the external geoid, external ground or geoid, if you click that, then you can select the file. And as this file, we're going to select the aster from Masbate, the one in LAZ format, because it's much more efficient. Masbate, aster masbate.laz. Before I actually do this, I want to convince myself that this actually makes sense. So I'm gonna temporarily load the aster also into my project as a project file, just to make sure I'm not doing something stupid here. So I'm adding to my flight scripts the LAZ file also for Masbate. And suddenly you see that's the aster for Masbate, and here are our scripts. So sanity check number 1, my scripts are inside the aster. That's important. It's not the aster for Bohol or for some other island. So, and they're in the same projection. The coordinates are in the same projection, otherwise they could be overlapping. Oh, it's likely the same projection. Now the next thing I want to do, I want to actually zoom in a little bit here. I want to see, I'm just picking a few, I use the pick operator now. Or maybe a bit more generous. Pick again. I want to see how the aster points and my LiDAR points, maybe more generous. This. I don't want to do too many LiDAR points, so otherwise it's slow. I want to see how those and process all files, otherwise I don't see all of them. Just visually, I want to see how the LiDAR points lie in the aster points. And I'm doing a little trick here. I'm adding files are light lines. You've seen that a few times. It's a bit long to write. I should make a FAF, minus FAF out of it. So in the future it would be much faster to type. This allows me to select individual files and only look at those. Make the points a little bigger. And now I can see the LiDAR points, which are super dense. And the aster points. And I can reassure myself that also it's not perfectly matching, you know, because of course there's much more mountains and so on in the LiDAR points. The clouds are much higher than the aster. So I can use the aster to remove the clouds by saying if anything is too high above the aster, it's probably a cloud. Let me just get some idea how high we're talking about. I'm picking the point here in the cloud. That is 747 meters, one of the lower cloud points here. And now I'm picking a point on the aster. Oh, missed it. 11 meters. Now I pick a point. Is the aster maybe in is the aster maybe on the geoid? Huh? Wow, then there's a huge difference. Well, if I press 0, 1, 2, I can look at the different ones. That's why I added minus files of light lines, so I can use 0, 1, 2 to look at the points individually. And 2 in my case is the aster, so I triangulate the aster. Triangulate. Oh no. Triangulating doesn't work. You know why? You know why? Because of the triangle monster. The aster is so coarse that the triangle monster eats everything. There's always a little triangle monster to eat the very big triangles. So I need to run my viewer again. I'm also viewing more points this time. I put the points up to 10 million. I haven't really mentioned that before. Last view removes points, so you don't have all the points. It just samples a few to give you an idea of the file. I also make it a little smaller. Maybe you have noticed that. You can directly edit the extent of the picked box here. So make it a bit smaller, 500, 400, 300. Yeah, that's sufficiently many LiDAR points to make the comparison. And if I now start view, I'm adding two things, and I really need to make a shorthand for this. Files of light lines, and I make the triangle monster less hungry, minus 0.5